Hello, my name is Jonathan Billings, and today I'd like to talk about AFS on Linux using AFS with GNOME, Systemd, FLATPACK, and security software. Today I'm going to be talking about mostly modern Linux systems and how they interact with AFS. I'm going to be using GNOME as my desktop environment, although there are a variety of other desktop systems, and they may work differently with AFS. I'm going to use Systemd for the OS init system, Wayland for the display system, and I'm going to talk about some of the different packaging systems that can sometimes interact with AFS. And lastly, I'm going to talk about software or security software used on Linux systems. My example system is going to be a Fedora 34 system. I'm going to be using an AuriStorFS AFS cell that I manage, and I'm going to be using kAFS in the Linux kernel. I will call out any OpenAFS or AuriStor specific differences. Keep in mind, GNOME, Wayland, and Systemd are all moving targets. They are constantly changing, and this may or may not affect the way that they work with AFS. I'm going to start with Systemd, since it is the core of the operating system. What is Systemd special? It is the current init system for most Linux distros. It uses a socket and dbus activation for managing most services, and it uses this term called a unit, which is what they use to describe the basic unit of managing systems in Systemd, including services, mount points, timers, sockets. And it also heavily uses C groups to manage processes. And we'll see that later. The most important thing that affects AFS I've discovered has been the Systemd user process. And this is a process that's launched by Systemd login whenever you log into a system that's managed by Systemd. This process is a child of the operating system's init process and not a child of your login process. And that means that it doesn't inherit any variables, environment variables, or the AFS PAG if you're using OpenAFS or your AuriStorFS. It also doesn't inherit the keyring if you're using kAFS. It runs through its own separate PAM stack, so it can have some PAM settings set to it. And by doing so, each login is contained in its own slice unit. And there's going to be one Systemd user process per user and not per session. And so desktop environments have just started using Systemd user services to manage actually the processes that are launched as part of the login, instead of it being a shell script that's started by whenever you're logging in. I'm going to use a tool called Systemdcgls. This tool lets me look at the system C groups that Systemd units use. It's a good way to kind of look at your C groups as on a system running Systemd. It kind of prints it out in the tree format, and you can kind of separate things out so you can get a good idea of what's going on. So let's take a look at a particular user's Systemd groups when they're started by Systemd user. There's multiple pages of output, so I'm going to separate it out onto separate pages. So this is the top of the output. As you can see, I'm just looking at user-1000.slice. That is the name of the Systemd unit that describes all the processes managed by or that are under my user. And the first thing you see is the session-10.scope. That is Systemd logind's session 10. Every process that is launched as part of the login process end up in here, and you can see right here, they are there, and you can see the PAM GDM password. So I logged in through GDM, and then there's a couple processes. You can see the GNOME keyring, GDM Wayland session, and GNOME session binary. Now, these are all processes that have an AFS PAG if you get that as part of your PAM stack. So these are the normal processes you would see in a login session that would have access to your AFS resources. So this is a little bit further down in the output. You can see I've escaped out the session 10.scope. You can see here that there's a user at 1000 service. This C group describes all the processes that have been launched as part of the systemd user process. And it does not have an AFS pack, or at least it doesn't have the one that you got whenever you logged in through the normal login process. So the first part of this is the session.slice, and this kind of describes all the processes that are started as part of your GNOME session. You can see here that there's a GNOME shell service unit that is created, and it includes GNOME shell, some iBus stuff, and Pipewire, which is the sound system on Fedora 34. And so moving further down, you can see there's this app slice. Now the app slice differs from the session slice. It is basically the processes that are started by the user once they've logged in. And so there's a dconf service that's probably was started by GNOME terminal whenever I started that, which you can see there. And if you look down deep in there, there's a bash process and me running Systemdcgls. So that's the command that I use to produce this output. And also GNOME terminal launches its own service. That way all processes that are run by GNOME terminal are actually just child processes of this little server. And lastly, you see this init scope, and that's a systemd unit that describes just the systemd user process. You can see it has its own sd-pam process. This is a process that's launched as a product of the systemd user PAM stack. So everything underneath that was in the user at 1000 scope that didn't have any AFS access. So, and also if you set up Kerberos to use a Ccache in /temp, it won't know the CC name, and it might not even have access to /temp because systemd can be configured to have a private /temp directory for every service. The systemd user process also can't read into the users .config/systemd, and that's the configuration directory for systemd user. And it might not be able to read that if your home directory is an AFS. Also, GNOME services such as dconf can't read the configuration out of the dconf directory. And any other processes that need to read out of home will have errors. So what do we do to solve this? We could run aklog as part of some systemd user service. And you'll want to make this be global. So you'll put it in the global directory because it can't read into your home directory. And what you'll do is you'll just basically have it run aklog as soon as it starts up, and you'll just want to make it be something that launches on login. Now, the problem with this is that you need to make sure that your Kerberos ticket is available to that. So you can't use the random file in /temp. I suggest using a persistent keyring or the KCM, and these are both C caches that modern, or at least MIT Kerberos supports. You also have to deal with the fact that it's possible that your Kerberos ticket and your AFS token might expire while you're logged in. If you've got short times or you just are logged in for longer than the lifetime of the process, you're probably going to want to be run something like krenew. And what I do is I basically replace the kstart with a krenew process that just basically periodically renews the Kerberos ticket and runs aklog. You can also use a systemd timer to do this. They basically do the same thing. It's just that krenew produces less log noise in the journal. Now that you've got this working, you've got a problem. You've set up tokens as a per user feature and not a per session. And if you actually log into a system multiple times, either through SSH sessions and graphical sessions or some other process, it's possible that you could destroy your tokens or Kerberos tickets in one session and cause the other session to have problems. This is possible if you do something like you need, using, if you want to be able to become an AFS admin while you're logged into the graphical console. You have to be very careful not to destroy the tokens for your GNOME session. When you do that, I suggest using an ephemeral curb5 CC name and also use the key control session. That's the key control session is something that you'd want to do if you are using kAFS. Obviously, if you're using OpenAFS, you should use pagged sh. Also, you should really keep in mind that the systemd user session lives outside of login and logout. Now, it's possible to configure systemd to kill all your processes when you log out, but you might not want to do that. And if you do so, that means that after you've logged out, there might be authenticated processes running on the machine, still doing something. And if you do log in a second time, you'll probably still have access to those various tickets and tokens. So if you are using the same user to log into a system with multiple different Kerberos identities, you might find that you have duplicates, or you give someone access to your tokens. So what do people usually do in these situations? Well, the first thing you can do is you can just not use Wayland. I found that if you're using Xorg, at least on Fedora, it basically looks like the old way, where basically all the processes that are started as part of GNOME are actually descended from your login session. But I'm pretty sure that the GNOME and systemd developers will eventually figure out a way to make it work just like Wayland. The other solutions, don't use GNOME. A lot of these things are GNOME specific. I have used Mate and it doesn't have as much of these problems, but I'm pretty sure that eventually a lot of these things are going to start using it. The other thing you can do is you can actually disable systemd user, and you can do this by running the command system control mask user at .session. And that's the specific syntax. And what that does is it basically disables the systemd user. Whenever you log in, it just doesn't launch. But the problem is that breaks GNOME and Wayland completely. You won't be able to log in. You won't even be able to log in through SSH sessions. So I think that if you are going to use anything modern, you're really going to have to learn to live with systemd user. So let's talk about some GNOME specific things. GNOME uses a thing called dconf for its user configuration. It uses a gvariance database file, which is usually stored in your home directory in .config dconf user. It's been optimized for reads. Dconf handles direct access to this using mmap, and then it kind of hides writes in a library. This is a direct quote from the documentation. It calls it a clever, fast mechanism that records the outstanding changes locally so they can be read back immediately until the service signals that a write has completed. And what this means is that writes are basically triggered by interactions with the settings. So either you're going through the settings, or you're running dconf gsettings commands, which are the CLI interface. And what it does is it kind of uses dbus to talk to the dconf daemon to tell it to write. And the problem is, if you're using AFS home directories, you might not even have access to the dconf database when you log in. It can have all sorts of issues with the mmap reading map method. Sometimes that doesn't work well with AFS. And the writes to the dconf database, it really has no concept of a shared file system. So, it's really use at your own risk if you're logging into multiple systems with the same home directory. There is a workaround. Basically, what you can do is put servicedb /key/file/user in the dconf settings. And what this does is it basically tells dconf to copy the content of the settings into the xdg runtime directory, which is /run user uid, and it periodically writes the settings back into your home directory as a text file instead of the gvariance database file. And this seems to cause less brokenness in dconf. It still doesn't support multi-login systems, but I found that it works considerably better. And plus, it's nice to have those settings as a text file, because then you can poke around and look at them as a regular user. The other problem GNOME has is if it doesn't have the ability to launch processes whenever it first logs in, quite often you'll get this, oh no, something has gone wrong screen. And really this happens quite often if you can't launch things like the Nautilus process, which is their file browser. The solution to this is to make sure you run that aklog systemd user process. And that seems to fix most of the problems with GNOME whenever you're having problems logging in. You'll want to make sure that your AFS tokens are auto-renewed for the lifetime of the session. Look back at my systemd section for that. And really, you should avoid using any of the GNOME indexers, GNOME tracker indexers. These things just hammer through your AFS directory looking for things, and they're pretty useless unless you have a really fast AFS file system. The file managers can also get confused and bogged down in AFS directories if they've got lots of volumes that they're looking through. And absolutely do not try to look through /AFS. It can have all sorts of problems. This is why I suggest if you're using OpenAFS to use the dyn-root sparse or fake stat. That will make it a lot happier. It won't try to descend into those directories. Okay, so let's talk about FLATPACK. FLATPACK is a package manager for Linux, and it uses something called OSTree for its managing its packages, which kind of lets you treat file system objects like objects as in a manner similar to Git. So you can layer things on top of each other, kind of like how you can do with Docker. It has a bunch of sandboxing features. So you can, and it uses some Linux specific features called like set caps, C groups, and namespaces. FLATPACK also can interact with your user session using Exegee desktop portal. And what that is it, since it's sandboxed, it only can access parts of your user environment through these portals. So it, if you restrict it so it can't actually talk to the devices on your computer, then the portal will not be allowing it. So if you can use FLATPACK with user repositories instead of just the operating system repositories, and it stores that stuff in your home directory. And then any application data is stored in .var/app in your home directory. Unfortunately, it uses hard links for a lot of the features that it runs to basically keep things so they're not stepping on each other, and it just gets really confused in AFS. And as far as I can tell, it just hangs whenever you're trying to install software into your home directory if it's AFS. However, if you install software as root into the root operating system and not into AFS, it launches just fine. Some software does fail whenever it's trying to launch hard links, sockets, and various other things, but that's just basically the same thing you'd have even if you'd installed it as a regular package. So you can see here, I had run the calculator, which is part of GNOME. That's a FLATPACK. I ran FLATPACK PS, and it tells me what's running. And yeah, it runs just fine. Anything that's a little bit more complicated than that, if it tries to do anything in your home directory, it can often run into problems. So let's talk about some Linux security software. I'm going to talk about SELinux and AppArmor. And then I'm going to talk about two kinds of security software. The ones that are just simple signature scanners in that they're looking for malware and various things based on what is in the contents of files. And then there's also reactive scanners. And these are scanners that kind of use features in the operating systems to see whenever processes are looking at files and then scanning them. SELinux, basically anything under AFS is labeled with the NFS_T type. And there's no way to label files in AFS with specific SELinux labels. So basically everything looks the same according to SELinux. You need to use the use NFS home dir's SELinux boolean if you have AFS home directories. And then for any services that serve content out of AFS, yeah, there are often SELinux booleans that you'd need to turn on for that, such as HTTP use NFS, FTP to use NFS, Ambushare NFS. All these things are called NFS because everything under AFS looks like it's an NFS file system. The software that uses SELinux to restrict access to various files or directories, it's just not going to work, or it will act like it's not a labeled file system. So you won't be able to get Chrome and Firefox sandboxing, or Firefox sandboxing, FLATPACK, anything it does to sandbox home directories won't be effective. And specific labels such as GNU-PG, OpenSSH, Pulse Audio, these all things on a regular Linux file system, they all have their own SELinux label, and you won't get that for OpenAFS. Now, AppArmor uses, instead of using file labels, it uses paths. And you can mark AFS paths in your AppArmor policies to be home directories or executable directories. And all you need to do is have a custom policy for your cell. So really, AppArmor seems to work better for AFS than SELinux. So as I was talking about, there are simple signature scanners. Basically, they just go through the file system and look at stuff. They are assumed that they're going to be running as root, and they can read everything. And obviously, if they're trying to go into AFS and there are AFS hackles that prevent access, they won't be able to scan anything. And you can always run it with AFS admin if you trust that, or give it AFS tokens. A lot of this software doesn't know what AFS is, and it can get lost in AFS, scanning some other person's cell. So make sure that if you're using it, you point it at your particular cell. A lot of security vendors, they just tell you to turn off AFS whenever you're scanning. I've encountered this on multiple occasions. And basically, if all your user data and all your deployed applications are in AFS, what's the point of running these scanners? Sure, yeah, you can look at systems that might have users on it that have temp directories and things like that. If you don't trust them, that's a good place to scan, but you're missing out on a large portion of your data. So one of the most popular open source malware scanners is kAFS. And you basically need to tell it to scan particular volumes, otherwise it gets lost in AFS. I found that it makes AFS unusable when it's scanning. And I actually managed to make my system hang when I tried to do a clam scan multi-scan, which is a multi-threaded scanner. And that might be my fault because I was running it on a host that was also hosting the cell as a virtual machine. So I'm not sure if that was the cause, but it's very likely my fault. So there are these reactive scanners, and they basically try to inject themselves into the operating system to be able to look and see when files are in use. And there's a variety of mechanisms they use to do this. There are custom Linux security modules that you can inject to make it do that. They can use the audit framework to look for file actions, and then you can use Linux specific features such as iNotify or FNotify. So the first one, let's go back to kAFS. It has this thing called on-access scanning, and it basically uses the FNotify to monitor and scan processes on demand. So basically, your OS opens a process and it goes and scans it. Unfortunately, you need to make sure it whenever you tell it to scan a particular directory, it opens up watch points for every single file in that directory. And it's very easy for it to run out of watch points. So it might not be all that effective if you've got a lot of files in a particular directory. And also, if you don't actually have that feature turned on, not all kernels do, it falls back to using iNotify, which is even less effective. And really, it has a lot of the same limitations as the on-disk scanners because kAFS, it's just telling kAFS to scan that file. And if it doesn't have access, it doesn't have access. I've also used CrowdStrike Falcon, and it uses a custom Linux kernel to monitor files. It looks for basically file open, close, execute, file system actions. And it uses some sort of machine learning algorithm that is proprietary to detect whenever there's some sort of nefarious activity going on. And this way it avoids having to do signature detection because it's not actually looking at the contents of the file. It's just looking to see what files are being opened and looking for patterns. And really, this should be an effective tool for AFS. Unfortunately, whenever I was using it, it caused the kernel panic whenever users logged in with AFS home directories. actually when they logged out. It caused a kernel panic whenever people would log out, and is because the kernel module was trying to look up a dereferenced, or trying to dereference some object that after it had been deleted and lost its user context. I've also used SOFS endpoint. It has a kernel module for on-access scanning. Unfortunately, it doesn't. I haven't been able to get it to work with any of the systems I have with kAFS. But you know, it seems to treat AFS as a network file system and it skips it. So I did not get very far with that. So really, with Linux security software, support for AFS is limited. AuriStorFS actually has a special file server configuration you can add that supports scanners either through an implied ACL or acceptor-only keys. OpenAFS, you really have to give, or kAFS, you really have to give it tokens with read and write access. I found that scanning is extremely IO intensive. It really reduces the performance for other clients. And with OpenAFS servers, increasing scanning threads won't really improve the scanner performance past a certain point. However, AuriStorFS does support more simultaneous threads. And my employer has managed to get 10 gigabyte network traffic over one scanning system before he managed to break things. So it was pretty impressive. So in summary, the AFS support in the Linux kernel really needs more. In summary, there is AFS support in the kernel, and that means there's going to be more widespread access. However, the GNOME and Systemd developers seem to have a primary focus on individual private desktops managed by the user and not enterprise operating systems. And so they don't really seem to understand how network file systems works, either AFS or NFS. And they basically have decided to redefine how Kerberos authentication should work. And either they're ignorant or they're ignoring how it's been used in the past. And there's workarounds, as I've described in this talk, but really what they need is more involvement from the AFS community. Thank you very much. I will post the slides for this talk later on. Also, I wanted to add, I'm planning on working on the CentOS kmod sig to get kAFS and OpenAFS kernel modules built for CentOS stream kernels. And please let me know if you're interested on working with me on this. Thank you.